Hey guys, here we go on lesson 19. So go ahead and open up to lesson 19, which is basically going to build off of lesson 18. So if you understood lesson 18, this is going to be pretty easy for you. So it says in lesson 18, you learned about multiplying fractions by whole numbers. In this lesson, you will multiply fractions by whole numbers to solve word problems. So basically all we're doing is just doing word problems. So here we go. 1 serving of crackers is 3/10 of the whole box of crackers. Bella ate 3 servings last week. What fraction of the box of crackers did she eat? Okay, so if we have the whole box is 3/10. Okay, so let me get my pencil here. All right, the whole box, and they have it shaded for us. Okay, this is what the serving is. Okay, 1 serving is 3/10. Now it says, what fraction of the box is 1 serving? Well, that's freebie information. It's 3/10. How many servings did Bella eat? Bella ate 3 servings. Did Bella eat more or less than 3/10 of the box of crackers? Well, if you look at our picture here, if 3/10 is 1 serving, and she did that 3 times, gave you your answer. Did Bella eat more or less than 3/10 of the box of crackers? Well, she ate more than that, because that was only 3/10 was only 1 serving. What operation are we going to use to solve this problem? We're going to do it the quick way. We're going to use multiplication. So, if Bella ate 2 servings, you could multiply 3/10 by 2 to find the fraction of the box of the crackers that she ate. So, they're having us here look at, well, if she ate 2 servings, let's do it the Mrs. Reed way. So I'm going to make this a little more. Okay, remember, 2 is the same exact thing as 2 over 1. I'm not changing anything. It's the same value. 2 over 1 equals 2. I'm just putting it over 1 so it reminds me not to do the top and the bottom. All right, 2 times 3 gives me 6. 1 times 10 is going to give me 10. So what fraction of the box did she eat? 6/10 of the box. Okay? Would have been the same exact thing as if we counted 1, 2, 3/10. Well, if she ate that twice, 4, 5, 6/10. Now it says explain how you could find the fraction of the box of crackers that Bella did eat. All right, well, she ate 3/10 of the box, 1 serving was 3/10, and she did that 3 times. You know how sometimes you get going? You start eating the crackers. Actually, I'm going to put it on this side. Sorry, I'm being rather indecisive. I always like to put my whole number first. You don't have to. That's just a preference with Mrs. Reed. So she got eaten, and instead of just eating 1 serving, she ate 3 servings, so she ate 3/10 3 times. Well, I'm going to put that over 1 so it reminds me not to touch the bottom. 3 times 3 gives me 9. 1 times 10 gives me 10. She ate 9/10 of the box. Now let me ask you, 9/10, is that close to none of the box? Remember, we talked about this. Where does that fraction lie? Is that close to none of the box, close to half of the box, or close to the whole box? Hopefully you said that that's close to the whole box because you've eaten 9 parts out of 10 total. So you've eaten pretty much the whole box. Okay? All right, let's keep going. So they're going to say find out more. To solve the word problems, you can multiply a fraction by a whole number. We know that. These problems include combining equal size parts. In the cracker problem, the serving size, 3/10 of a box, is the equal size part. You can add 3/10 each time Bella eats a serving, or you could use multiplication. So if I were to ask you 3 times 3/10 is the same as saying 3/10 plus 3/10 plus 3/10. Do you agree? First, she ate 1 serving, she ate 2 servings, she ate 3 servings. Writing it this way and writing it this way are exactly the same, except multiplying is a lot faster to do the work. So it says eating 3/10 of the box 3 times can be written as 3 times 3/10. Let's not do that. Do it our way. Put it over 1. All right. So, yeah, we did all this. We already did this. So now we're going to reflect. Describe a real situation where you might want to multiply a fraction and a whole number. There are an infinite number of answers for this problem. So I'm going to let you decide what you want your real life situation to be where you could multiply a fraction by a whole number. If you're stumped, I will tell you that cooking is a very, very real example. Anytime that you're cooking something, let's say, like we talked about that problem before, you have the 1/4 size cup, but you need 6 of them. What might you do? Okay, so try to come up with an example on your own to reflect. If you need to, you can pause the video right here so that you can write. I'm going to keep going. All right, so here we go. Another problem. James is baking cookies. 1 batch of cookies needs 2/4. Oh, there we are right there, baking, cooking. 1 batch of cookies needs 2/4 of a teaspoon of vanilla. James wants 3 times the number of cookies in 1 batch. So let's say that the cookies, the recipe that James is using only makes 25 cookies, but he needs 75 cookies. He needs 3 times that amount. So he's got to triple or multiply by 3 the recipe. So James needs 3 times the number of cookies in 1 batch. How much vanilla does James need? Well, they made a picture for us. They made it pretty easy. So they say 3 times as many means 3 batches. The picture shows 1/4 teaspoons for 3 batches. So he's going to need 1/4 here, or actually, I'm sorry, 2/4. Okay, so that's 1/4 and 1/4 makes 2/4. So he needs 2/4 for this, for like batch number 1, if you will. He needs 2/4 for this and 2/4 for this. Now, he could probably make this whole batch in 1 bowl. Okay, so he's figuring out how many times he's got to fill up that 1/4 spoon and dump it in. Okay, he's not making 3 separate things. So if we count them up, 1, 2, 3, 4, 5, 6, we have 6. What's the size? 1/4 size spoonfuls. Okay, so that is 6 1/4 size teaspoons. All right, let's look at the model it. You can also use fraction strips to solve the word problem. So the fraction strip below is divided into fourths and shows 2/4, the amount of vanilla in each batch. Yep, there it is. Hopefully you can tell what's shaded, just in case. Okay. All right, so for batch number 1, he needs 2/4. Batch number 2, he needs 2/4. Batch number 3, he needs 2/4. If I count them up, that is 6 1/4 size pieces. Okay, easy peasy. All right, let's flip it over. Now I think they're going to have us apply it. Yeah, we can do this. Now, how much vanilla does James need for each batch? We know that he needs 2/4. And if you didn't remember that, or you were a little fuzzy on the number, flip the page back over and look. Never guess. How many batches does James want to make? Well, he wants to make 3 batches. So he needs more cookies than 1 batch will allow. So he's got to do it. He's got to do 3 times all of the ingredients to make 3 batches. So we take the number of batches, 3 batches, times the number of teaspoons he needs for 1 batch. Okay, so he needs 2/4 3 times. We're going to throw that over a 1 because that keeps the same value. and multiply across, which is going to give us 6/4. Right? 6/4. We're done. Looks good. Hopefully you said no. Even though they're not asking for it, we're still going to change this because this is not proper. Improper fraction. Too many pieces to make a whole. All right. How many times can I count by 4 until I say 6 without going over, or till I get close to 6 without going over? 4, 8. Oh, I'm already over, so I can only go in once. 4 goes into 6 one time. When I do that, how many pieces do I have left over? I have 2 pieces left over. And what's my size? 4ths. Okay. Explain how you can check your answer by using repeated addition. Well, if I need 2/4 3 times, that's exactly what I just did. 2/4 3 times. 1 time, 2 times, 3 times. And when I add those together, add your pieces, not your size. Add your pieces, not your size. Same thing. Make it proper. Beautiful. All right, let's talk about Micah. We're going to try it. Micah jogged 8/10 of a mile. Sarah jogged 3 times. Oh, look at that. Freebie information. 3 times this distance. How far did Sarah jog? Well, we know that times means multiplied. 3 times 8/10. 3 times. So Micah jogged this much. Sarah jogged 3 times that. Okay? Now, when I have my whole number like this, if it's hard for you to remember to stay on top of the line, then you can rewrite it like this. Okay? But if it's okay for you, then keep it like that. So let's solve this, and then I want to touch on something. So 3 times 8 is 24. 1 times 10 is 10. Now, I want you to take a look back. Do you notice that when we multiply, it is okay to multiply the denominator? Did you notice that? But when we're adding, you do not touch it. That's because multiplication is addition repeated, and when we have repeated addition or any addition of fractions, you don't touch the denominator. This is just telling me how many times I'm doing this fraction. That's why it's okay to multiply the denominator. All right, so when you multiply, it is okay to multiply the denominators. When you're adding, you cannot, because you're putting those pieces together. All right, so hopefully you're sitting and you're waiting and you're thinking, okay, Mrs. Reed, you explained why you can do it with addition but not why you can do it with multiplication but not addition, but we still have a problem. 24/10, what's wrong with that? Hopefully you said it's an improper fraction. All right. How many times can I count by 10 until I get to 24? Or how many times can 10 go into 24? 10, 20, 30. Oh, that's too high. So 2. I'm just putting it down here because my little mark's there. All right, when I take my 2 groups of 10 out of there, how many pieces do I have left over? 4. What size? Tenths. 2 and 4 tenths. So Sarah jogged 2 whole miles and then 4/10 of a mile. All right, on Monday, Sylvia spent 5/12 of the day driving to her cousin's home. Is that more or less than half the day? Hopefully you said less. Half of the day would have been 6/12. So she spent 5/12 of the day driving to her cousin's house. On Friday, she spent the same amount of time driving home. What fraction of a day did Sylvia spend driving to her cousin's house and back? So she went 5/12 of the day 2 times. So 2 times she went 5/12. Slap that over 1 so I don't change the value. 10/12. She spent 10/12 of the day driving to and from her cousin's house. Do I need to turn this into an improper fraction? Or I'm sorry, do I need to turn this into a mixed number? Hopefully you said no. It's not an improper fraction. I haven't even made it to 1 yet. I only have 10 pieces, or 10 out of 12. So it hasn't even made it to 1 yet. This is not improper. We're good to go. Okay. All right, that looks like the end of lesson 19.